Hi there. This should be short. You can see here I've got a GIF running of pictures of the sun that I took all day today, every hour for 12 hours, because it was reasonably sunny most of the time. You can tell when the clouds got in front of the shot. But this is the P900 on moon mode, which interestingly enough works really well on the sun. They pretty much, whether it's the sun or the moon, the camera doesn't know what you're looking at, but you tell it, and it presumes the right, framing and focus and all that for the moon. Well, it works really well for the sun. Hey, Mark. And but mainly what I wanted to show here is that it's really not changing size throughout the day. Now, granted, I don't have a good view of the horizon. I've got, I'm in the suburbs and I could go drive somewhere and get up on a higher elevation and do this, but I'd have to sit there all day long, and I'm not going to do that. So the thing is that every hour, hey, Lane, this was I took this shot. All the settings are the same, and of course I cropped it to fit the size of the first image, and I just put all the rest of the images in the stack, and they line up perfectly. If there are changes in size, they're extremely minor and not obvious enough to say, well, the sun shrinks or grows or whatever. It's very consistent. And this is, I've talked about the lensing issue with the sun before, is actually kind of an issue, because although I've never been able to get the kind of lens I would need to prove or disprove that theory, the problem is that if you're looking through a lot of distortion, which seems to account for sun movement laterally across the sky, as I'm going to just do a little reminder of, it works for that. But you would think that the sun would be changing size as well, but that's not necessarily so. Again, I would have to do an experiment. I'm just making that point. And the thing is that, whoops, I didn't want thumbnail on. Sorry about that. It doesn't change size. Okay. Now I'm going to go to the next thing. This is when last summer I tracked sunspots. There have been precious few. And there was about a week when we had clear skies and some interesting spots to watch. Well, what I did was watch the clock motion of the sun during the day. Hey, Ross. Yeah, this would be an interesting experiment for other people to do at different latitudes and longitudes, especially north and south of the equator, compare those. But I'm just saying, in my location, this is what I'm observing. But that would be interesting. But as I've got here on this clock motion issue, which, like I've said, I've done more extensive videos on these, but just a quick reminder here, that we have a clock motion going on, as the sun is doing four directions of motion. It's going horizontally, vertically, it's going north and south, and it has a clockwise motion. And what I'm illustrating in this drawing was the beginning and ending points of the spots. They started at the beginning of the dark lines and would rotate around like this through the day. And depending on where they were on the clock face, they would travel different distances, because that's what you would expect. And it's like a wheel with spokes going out. The ones, if you turn it a certain RPMs, revolutions per minute, the ones on the outside are going to travel more distance. This is, something you can duplicate and experiment for yourself and verify. If you get a bike wheel or something and put spots along the line of, one of the spokes, and spin it, all, the whole wheel moves, at one speed, but the spots are going to travel more distance depending on how far they are from the center. Well, that's what sunspots are doing. And then I tracked them over the course of a week, and they went, this spot eventually got toward the center and moved very little because it was in the inner part of the wheel. And the same for all the other spots. The yellow line is the course of the week of the beginning of that spot, and then the blue line with the arrow is where the spots wound up at the end of the week. So we have that clock motion. But what's interesting is that the rotation speed of the sun seems to be higher at the middle of the day. It rotates faster when it's at its zenith or its highest point in the sky, which is interesting because, especially if we go to this one, that's just another one of my reminder things, is we have these two things to think about: altitude and azimuth. Azimuth is along the ground. Altitude is above the ground, okay? Azimuth, as I say here, is always, it's points north. That's what a compass basically is measuring, azimuth, okay? It starts at 0 or 360 because there's 360 degrees in a circle. They're both the same point. You point that north. That's always, anywhere on Earth, you're going to point your compass north. You know, that's where the needle will point anyway. And that's the 0/360 point. And then you go around clockwise from there. And so, you know, a quarter of the way is 90 degrees, and then another 90, and you're back. So that's azimuth. And so the highest number of degrees is 360. And yet at altitude, the highest degrees is 90. Straight up is 90 degrees. So you'll never be higher than 90 degrees. So we got, you know, where the sun is moving in three-dimensional space. And also I've noted before on my main sun video, Challenging Standard Cosmology, the Sun, that no matter where you are on Earth, think of looking straight down on the Earth's surface. These arced lines here that make it look like a baseball are the sun's path at any individual location on any given day. So on the same day, if there's one person in the northern hemisphere, one in the south, and they're facing each other, they're both facing the equator. Okay, this line is the equator. If you're looking down at the sun, it appears to go south and then north, or in, you know, below the equator, it goes, north and then south, and then below the equator, it goes south and then north and then back south again. So that it pinches toward the middle as it reaches its highest point. And that's when the clock motion is fastest, okay? So what's curious, what I did today, I plotted a graph. I went into just, you know, open office, and I wrote down every hour of the day the altitude and azimuth of the sun at each of those points when I took a picture. And you would expect a smooth motion, wouldn't you? If it's due to Earth spin, the sun isn't going to speed up and slow down in its speed of traveling across the sky. Now, altitude is the blue line here. That's pretty predictable. It's low in the sky, and then it rises to its highest point, and then it goes low in the sky again. That's, like I said, altitude. It's you know, if you are, you know, have a good angle measurement of something's location in the sky, how high up it is, and like I said, it won't go past 90. And in my latitude, it won't go really much past 70. You have to get at the June equinox or June solstice to see the sun go a little bit over 70 degrees where I live. But anyway, if you were at the equator, it would go to 90. Or in the tropics, certain times a year, depending on which season, any place within the tropics, there's going to be a time of year when the sun goes 90 degrees overhead. That's why they're the tropics. But it follows a smooth curve because it rises and falls, and it's very predictable, 15 degrees per hour. And that's a nice smooth curve. But why isn't azimuth a smooth curve? And granted, it's always going to go up because it's trying to go from, you know, basically a little less than 90. As we can see here, it started at 84 because it's summer in the northern hemisphere. And so it's a little bit north of east when it starts, and it will set a little bit north of west. So it'll go a little bit over 270. See, it went to 280 today, at least, and that wasn't quite setting. Okay, the day is longer than that. I did not get it right at sunrise and right at sunset. This is partial, so that's why it has the range it does. But the thing is, you know, it's following along this blue line, and then all of a sudden it jumps when it gets to the middle of the day, in which, by the way, also the rising and falling of the sun's altitude slows down in the middle of the day. Why does it do that? I mean, it should be, a smoother curve than that. It should not go up at an angle and see these three dots? They're not very far apart. But then the rate of change is more, and you can see that on the azimuth column here of, the fact that in the middle of the day, the jump in numbers gets higher. It's only like 6 to 10 degrees, as I measured last summer also, at the extremities, but it gets, like 20 or 30 in the middle of the day, the jumps from 1 hour to the next as far as where it is along the azimuth. But the altitude slows down. But why does the azimuth jump all of a sudden in the middle of the day while it's also speeding up its clock rotation? Okay. But as far as being slower when it's nearer, that doesn't make intuitive sense to me, because if you were to be standing, say, a few yards away from a long straight road and you see a car approaching and you're recording it, you don't have to pan your camera hardly at all when it's coming toward you. But when it's near to you, you have to really turn fast. You pan the camera fairly fast because it's going to zoom right past you. And then you don't have to pan much after that when it's going away from you. That's just, anybody's experience, especially if you've been like to a racetrack or anything. You can follow the cars easily when they're either coming toward you or going away from you, but when they're right in front of you, there's just a blur. So the problem with, and I'm kind of trying to interact with the chat there. The problem with invoking parallax is that if this is due to Earth spin, that shouldn't be an issue. I mean, we're spinning over the course of 12 hours, supposedly, and why such a big jump in the middle of the day when it should be, in my opinion, the spin rate is consistent, right? So, but like I said, if you see something approaching, it goes faster when it's right in front of you. It's going at constant speed. It seems to go faster when it's nearer to you. Okay, so this seems to match that kind of an observation. The approaching car, it suddenly zooms past when it's right in front of you. But when it's approaching or departing, the rate of change is slower, so you don't have to pan the camera as much. But the middle of the day, I find very curious. Like I said, the sun's altitude change is slower in the middle of the day, but its clock rotation and change in azimuth, its horizontal speed, increases in the middle of the day. Which, again, I find counterintuitive to the idea that the Earth is spinning at a constant rate and the sun's not really moving at all. And you can track with a sundial, it absolutely moves a very steady 15 degrees per hour. But if that's true, if it's, and that is azimuth, then, I mean, as far as the shadow goes, but its actual azimuth angle is really speeding up in the middle of the day. So we have two things speeding up in the middle, like you would expect an object that is coming towards you and then going past right in front of you and then going away from you. You would expect things to happen faster right in front of you at the zenith, in the middle of the day. And that's what I'm seeing here on this chart. Except, I don't have rotation on here, the clock rotation. It's just, you'll have to trust me from my former video, that it spins faster when it gets here. So it's going across the sky faster and spinning clockwise faster in the middle of the day, but it slows down its rate of change on this altitude, which again doesn't, I just, you'd have to do experiments to duplicate with, objects, on a much smaller scale. But yeah, this has really got me wondering, hey, mid Thanks. Yeah, I just came up with that. It was actually that some Ting Wong was from a hilarious news story a couple years ago that a plane crashed and they were all Oriental names, the pilot and everything, and they had some pretty, somebody was messing with the newsroom and had some pretty good names, and that was one of it. But um, let's see. As it gets further, though, it's moving further. We see it moving through less visible space. Hey, Pillbox. Let me read your comment again. Yeah, that was totally fake news. It was funny though. But anyway, I guess further, it's moving further. We see it moving through less visible space. Well, that, like I said, that would kind of match up with the lensing thing where you have less distortion right in front of you. If you're looking straight through a lens, you have very little distortion. So yes, lenses can make things appear to move faster at the edges where the glass or whatever material it is thicker. But mainly I'm just saying, how people will say, well, the sun, there's been videos of the sun appearing to go not in an arc so much as getting, starting on one horizon, very tiny, getting maximum size in the middle of the day, and then getting tinier as it goes to the sunset. But I haven't seen any of those done with a filter. The pictures I took were with a filter. And like I said, I don't have a good view of the horizon, but the sun did not change size at all over a 12-hour period. So the thing is, using sun size when you have a filter, it's not changing. You can't say, well, it looks like it's perspective, and I've had another perspective video where I'm like, the sun doesn't seem to fit that, the sun and moon. And I postulated that that's because they are above the lens, and that's why they don't follow the perspective rule, because that only applies on our side of the lens to, when things are coming and going, even jets up in the sky, they're still on our side of the lens. So perspective can be invoked, and it's obvious, and you can see things, very tiny in the distance and larger close up. But let me get back to this graph. If the sun is outside of the lens, then we have this distortion as far as its position, its apparent position goes, and it would account for the slowing down of altitude. But I'm not sure if it, like I said, it isn't convincing for the videos of the sun seeming to be smaller at the horizons when they didn't use a filter, because the atmosphere is going to provide some filtering and make it look smaller. But this, I think, is a better argument for the sun coming and going, because it's faster when it's right in front of you, like any other object coming and going. So I think that's mainly the point I wanted to make, is that if you're going to say the sun is going in a straight line, basically, and the lensing can account for the north-south movement, then it would make sense that it's going faster when it's nearest you. And so this graph, the red line, is telling me that the sun may, in fact, be approaching from a distance, coming near and then going away, rather than arcing. So I'm just saying, I think that's a little bit better data to back up that argument. Yeah, seeing that we are, in my opinion, likely looking through lensing, we don't know the sun or the moon or anything else's real size. That's why it's impossible to triangulate, and why parallax really doesn't apply, because we don't know what kind of distortion we're looking through. We can't say, like I said, the best place is to look straight overhead, and to minimize distortion. But still, you have to, that's a very narrow window of watching, and that if you wanted to get size of something, that would be it. But you still don't know the distance, and you can't know the size if you don't know the distance, or vice versa. So there's all sorts of variables that we can't really get around. But like I said, the main point of this tracking I did today was just to show that there is a better argument than the visual for sun size, we can go by sun speed, and it makes a better case, in my opinion, for if one wants to make the argument that the sun is in fact moving over the Earth rather than the Earth spinning, because like I said, Earth spin without that lensing, especially as in the standard model, and that's what I always challenge. Earth spin does not account for that change in speed, in my opinion. So yeah, when people are trying to say how far away these things are or how big they are, they've got too many unknown variables. And so that's kind of pointless. But again, I think that sun speed being faster in the middle of the day it's undeniable by the data points, and these are verified by time and date for my location at least. So I'm using standard cosmology data and taking my own pictures to verify the sun is not changing size for a 12-hour period. So granted, the distance isn't what I would prefer, because you'd have to have maybe hundreds of miles, whatever, to as far as you can see to get the proper sun size with the filter. But in the absence of that, like I said, the size, at least as far as I could determine, did not change. But the speed change in the middle of the day as it goes across my field of view is a better argument for that, better data to support that argument that the sun is moving, coming toward us and going away from us. That's what I'm saying. Let's see, back to the chat. It appears to move in the inverted V, so getting closer is also climbing higher to our view, but always parallel. Let me read that again. Appears to move in the inverted V, so getting closer is also climbing higher to our view, but always parallel. I think I get what you're saying. But yeah, I've said when I did my earlier videos that blue line, where it slows down its altitude climb, you could be seeing it like if you were standing on the ground and that blue line is just something going away from you and then turning around and coming back, it would seem to slow down at the zenith. But it also works horizontally as well, like you say. But as far as the curve. But like I said, it's a slower rate of change in the middle, which I would expect that curve to be smoother. Yeah, it is hard to describe, but I just think it's a curious comparison between altitude and azimuth for why that really sudden jump in speed on azimuth, which is the horizontal movement across our field of view. If we're watching the sun, turn our head to the east and watch it go across the sky to the west, we have to turn our head faster when it's right in front of us, just like a speeding car, that we've seen coming from a distance. So as for why the sun doesn't seem to be smaller at the horizon, it could be a lensing issue. I mean, that's the moon obviously seems to be bigger, although I can't verify that either. I don't have enough horizon view distance to say whether the moon is appreciably larger. If you have a P900 or just very religiously consistent with your settings as far as zoom on the moon, and you take pictures of it at the horizon when it seems to be very, very large, and then again when it's at its zenith, and see if the pictures make the moon the same size, if the camera, because it's not going to be fooled by anything around it. It's just going to say, I'm at a certain zoom level, and if the moon is the same size in both shots, then it's not changing size because of any optical reason. We know it's not changing size physically, obviously. Sometimes you have to say those things, but that would be a good experiment for people. I usually don't, I try to avoid going out at night. I'm already covered with mosquito bites, but I don't have enough view of the distance to the horizon to do a good one on the moon. But, and I don't like to stay up at night anyhow. So there you are. Another puzzle piece. Not that I'm, answering anything. I'm just questioning things. So there you go. That speed change is kind of interesting, especially if the sun's movement is only apparent because the Earth is spinning. The sun is standing still. What would make that speed change in the middle of the day? So, size perspective won't change visibly because it's already sufficiently far enough away. Hard to say. Hey, Truth Freeze. Yeah, that's just, like I said, I stole that title from an old news story that somebody in the newsroom was just messing with the announcers who were just reading names, and somebody made up a bunch of fake Oriental names, and some were really, the newscaster did a good job of saying them without saying them the way the prankster meant them to be said. So they would say some dirty words and stuff. But anyway, some Ting Wong wasn't a bad one. Anyway, that's all I have as far as sun puzzles today. Like I said, this was my project today, and the pictures showed it didn't change size, and the data points show that it did change speed. So there you are. Yep, sun Ting Wong. So let's see, shouting everybody out again. We have Mark, Elaine, Ross, Mid, Pillbox, and Truth Freeze. Yeah, people, I never seem to have any to think of buying some when I go to the store. Some tea tree, eucalyptus. There's all sorts of home remedies you can get, but I, of course, never have it handy when I suddenly want to go out and take a picture of something at night. Yep. Yeah, let's scratch our heads instead of mosquito bites. But it's for science, so I gave blood for science. The gift that keeps on giving. So anyway, I think I'm done with this, so I'll probably shut down. Let me know if you want to do anything, Pillbox, with the other channel. Yeah, I think also, Ross, I should think of things to. I know there's those tiki lights that you can put out to an area to keep them out of the area would be nice also. Geranium oil, geranium oil is for ticks, but peppermint and clove. Okay. Yeah, they can really be a problem. So, like I said, though, I need to remember to go and find those somewhere. We do have a natural store around here. I should be able to find them at. Some natural remedies. Alrighty. Well, I'm gonna shut down because that's all the puzzle pieces of the sun I have tonight. So thanks for coming. See y'all later.